Welcome back to Maths with RP. We have been solving problems involving differentiation. Today we are going to solve more and more problems involving the concepts of differentiation. So look at this problem. We are given root of 1 minus x power 6 plus root of 1 minus y power 6 is equal to a into x cube minus y cube. Okay. Now you have to prove dy by dx is x square by y square into root of 1 minus y power 6 by 1 minus x power 6. This is what we need to prove. This is what is given to us. So we are going to make a substitution x cube equal to sin a, because I want to use the fact that root of 1 minus sin square theta is cos square theta. Okay. So then what I should do, I can call x cube as sin a and y cube as sin b. Okay. Then what will happen to the given data? Root of 1 minus sin square a plus root of 1 minus sin square b is equal to a into sin cube is sin a minus sin b. So you get cos a plus cos b divided by, I am bringing the terms here, sin a minus sin b is equal to a, which is a constant. Now let us simplify this further. What is cos a plus cos b? 2 cos a plus b by 2 cos a minus b by 2 divided by, what is sin a minus sin b is 2 cos a plus b by 2 sin a minus b by 2. This is a. Common terms I am cancelling off, so that this simplifies to cot of a minus b by 2, cos of a minus b by 2 by sin of a minus b by 2 is cot of a minus b by 2, which is equal to a. So a minus b by 2 is cot inverse a. In fact, a minus b is 2 cot inverse a. Okay. So from here you get a minus b by 2 equal to cot inverse a. Then I have taken this 2 to the other side. Now what are a and b? Sin inverse x cube minus sin inverse y cube is equal to 2 cot inverse a. So this is only simplification of the given function using trigonometry. Only now I am going to differentiate. Okay, so the differentiation process is here. Okay, so what is the derivative of, if y is sin inverse x, dy by dx is 1 by root of 1 minus x square. Okay, now here what do we have? This is what we have, and I have to differentiate. Sin inverse x cube will be 1 by root of 1 minus x power 6 into derivative of x cube, which is 3x square, minus 1 by root of 1 minus y power 6, because root of 1 minus derivative of sin inverse x is root of 1 by root of 1 minus x square. So since I have y cube square is y power 6 into 3y square into derivative of y is dy by dx is equal to the derivative of cot inverse A is 0 because cot inverse A is a constant. Is it clear? Now since it is equal to 0 I am cancelling off 3. So what do I get? X square by root of 1 minus x power 6 is equal to y square by root of 1 minus y power 6 into dy by dx. Therefore, dy by dx is equal to x square by y square into root of 1 minus y power 6 by root of 1 minus x power 6. So we have proved what we needed to prove, that is dy by dx is x square by y square into root of 1 minus y power 6 by 1 minus x power 6. Now look at this. You are given cos inverse of x square minus y square by x square plus y square equal to tan inverse A. You have to prove that dy by dx is y by x. So cos inverse of x square minus y square by x square plus y square is given to be tan inverse A. Okay, so x square minus y square by x square plus y square will be equal to cos of tan inverse A. Okay, now I can write x square minus y square is equal to x square plus y square into cos of tan inverse A. Okay, now what is it that you need to find? You have to find dy by dx. So 2x minus 2y dy by dx will be equal to 2x plus 2y into dy by dx into cos of tan inverse A. Okay, now I will get cancelling off this 2 everywhere. I get x minus y dy by dx is equal to x plus y dy by dx into cos of tan inverse A. Okay, now let me collect the terms dy by dx because that is what we want to find. We want to find what is dy by dx. So, minus y dy by dx. So, when I bring this here, what will I get? Minus y into cos of tan inverse A into dy by dx will be equal to x into cos of tan inverse A. This x, if I take to that side, will become minus x. So, dy by dx minus dy by dx will be y plus cos of tan inverse A equal to x into cos of tan inverse A minus 1. Okay. Now, I'll take this minus to this side. So, this will become x into 1 minus cos of tan inverse A. Dy by dx into y plus cos of tan inverse A is equal to this. So, what is dy by dx? Let me use a different color. So, dy by dx will be equal to 1 minus cos of tan inverse A into x divided by Here also I have one y. I have left out that y. So this is y into 1 plus cos of tan inverse A. Okay. Now, is it x or y? dy by dx will be x by y. Okay. Now, what is cos of tan inverse A? Cos of tan inverse A is this. Okay. So, I am going to substitute for that. Let me I'm just removing, and I'm just continuing. Dy by dx. See, here I had minus y dy by dx minus y dy by dx into cos of tan inverse A is x into cos of tan inverse A. This x I brought to that side, which is minus x. So this is x into cos of tan inverse A minus 1. This is minus dy by dx into y plus y into cos of tan inverse A. So dy by dx into y plus cos of tan inverse A is x into 1 minus cos of tan inverse A. So dy by dx is x by y into 1 minus cos of tan inverse A by 1 plus cos of tan inverse A. Okay, so now I'm going to substitute dy by dx is equal to 1 minus x square minus y square. What is cos of tan inverse A is this. So 1 minus x square minus y square by x square plus y square divided by 1 plus x square minus y square by x square plus y square, okay, into x by y. This is, when I simplify, what will I get? Okay. Okay, now when I simplify, what will I get? dy by dx is equal to x square plus y square minus x square plus y square divided by x square plus y square plus x square minus y square into x by y. Okay, now x square gets cancelled. Here y square gets cancelled. So giving you 2y square into x by 2x square into y, which when simplification gives you y by x, which is what we wanted to prove. So the idea is cos inverse of x square minus y square by cos square plus y square equal to tan inverse A. You write x square minus y square by x square plus y square as cos of tan inverse A. That is the most important step. Then I have cross multiplied, and then I have differentiated 2x minus 2y into dy by dx equal to 2x plus 2y dy by dx into cos of tan inverse A. Then I have collected the terms containing dy by dx. I have a minus sign, I brought it there and written cos of tan inverse A minus 1 as 1 minus cos of tan inverse A. So from that you get dy by dx is this. Okay, but we need to prove dy by dx is y by x. That means we have to get rid of cos of tan inverse A or by rewriting it in terms of x and y. How do we do that? Look at our second step. This was our second step. Cos of tan inverse A is nothing but x square minus y square by x square plus y square. So I have substituted for cos of tan inverse A. Then you get 2y square x by 2x square y. 2 gets cancelled. 1 x gets cancelled and 1 y gets cancelled, giving you y by x. Is it clear? Have you all understood how we got dy by dx as y by x? So it involved a little bit of manipulation and simplification, and then using the process of differentiation. So when you are dealing with derivative of inverse trigonometric functions, let us recall some of the properties. You know that sin inverse x plus cos inverse x is pi by 2. Okay, sin inverse x plus cos inverse x is pi by 2. Okay, whenever x belongs to the closed interval minus 1 comma 1. Okay, now how do you prove this? Okay, if I take sin inverse x as y, then I know x is sin y. Sin y can be written as cos of pi by 2 minus y. Okay, so cos inverse x is pi by 2 minus y. So sin inverse x is y, cos inverse x is pi by 2 minus y. So combining these two, I am going to substitute sin inverse of x plus cos inverse of x is equal to, sin inverse of x is what I have called as y, cos inverse of x I got it as pi by 2 minus y, so it is pi by 2. Same, by similar arguments, you can also prove tan inverse of x plus cot inverse of x equal to pi by 2 for all x in R. The first one is when x belongs to the closed interval minus 1 comma 1. Now secant inverse x plus cosecant inverse x can also be proved to be pi by 2 for all x in R minus the closed interval minus 1 comma 1. I've used the fact that the principal domain of sin inverse x, you all know, is minus pi by 2 to pi by 2. So is tan inverse x. Whereas for cos inverse x, the principal domain is 0 to pi. So why is principal domain important? What is the definition of a function? For every x in capital X, there should be a unique y in capital Y, right? But whereas if you look at the sine function, you know that sine 0 is 0, sine pi by 2 is 1, sine pi is also 0. Okay, so it is, so when I take the inverse, I need to restrict the domain so that all the property of 1 to 1 of the function is maintained. That is why we take the principal domain of sin inverse x as minus pi by 2 to pi by 2, because in that domain all the values will be taken only once. So the 1 to 1ness property and the onto property of function will be satisfied. When a function is 1 to 1 and onto, it has got an inverse. Okay. Now what is inverse of, what do you mean by actually inverse? If sin inverse x is y, x is sin y. Okay, and sin inverse of sin x is x, cos inverse of cos x is x, tan inverse of tan x is x. Okay, in the principal domains. So this is very, very important, because this is a concept that we are going to repeatedly use while we solve problems. See, for example, if I want to find dy by dx, now y is given to be sine inverse of 3x minus it should be 3x minus 4x cubed. Okay, now you have to recall the formula for what is sine 3 theta. You know that sine 3 theta is 3 sine theta minus 4 sine cube theta. Cos 3 theta is 4 cos cube theta minus 3 cos theta. These are some of the concepts that you have learnt in class 11 in the topic of trigonometry. So now here nothing is mentioned about the domain. So we can just use the very obvious substitution. I'm going to call x as cos A. 3 sin A. Let x be sin A. then y will be, in fact I can use theta so that you understand it is an angle. So y will be sine inverse of 3 sine theta minus 4 sine cube theta. This is sine inverse of sine 3 theta, which is 3 theta. If y is 3 theta, this is 3 into, what is theta? Sine inverse x. So dy by dx will be 3 times derivative of sine inverse x is 1 by root of 1 minus x square. So are you able to follow how we got dy by dx is 3 by root of, because y equal to 3 theta. Theta is what? Sine inverse x. So 3 times sine inverse x. The derivative of the, sine inverse x is 1 by root of 1 minus x square. So dy by dx is 3 times the derivative of sine inverse x, which is 1 by root of 1 minus x square. Suppose you have y equal to cos inverse of 1 minus 2x square. So what substitution is obvious? So you know that cos 2 theta is 2 cos square theta minus 1. It is also 1 minus 2 sine square theta. So this should remind you of this formula. Then you will know what substitution you have to make. So now I am going to write x is equal to sine theta. Then y will be cos inverse of 1 minus 2 sine square theta, which is cos inverse of cos 2 theta, which is 2 theta. So y equal to 2 theta. But what is theta? This is 2 into, from here, when x is sine theta, theta is sine inverse x, 2 sine inverse x. So y equal to 2 sine inverse x. So dy by dx will be 2 by root of 1 minus x square. Is it clear? Are you all able to follow? I hope you found this session useful. We will do a lot more problems in the next session based on differentiating inverse trigonometric functions. Until we meet next time, it's good.